Gravity? I know what you're thinking. I don't need a video to tell me about something that happens to me every day. The first two names that come to mind when talking about gravity is Newton and Einstein, with Newton's idea of how everything has a gravitational attraction to each other, and with Einstein's of how space-time wraps around things with high mass, like shown below. Now, the reason why we think that there are such things called gravitons is due to the fact that, like electromagnetic waves, such as light, which is both a particle and a wave, the photons, which carry quanta of energy, like low parts of energy. Now, if we took this as a gravitational wave, like we just recently found, then these waves must also have chunks of gravity, called gravitons. And we know this because through gravitational waves and the LIGO systems, we were able to find different parts of gravity at different parts of the wave, which could be shown as the graviton. A theory that gravitons work very nicely with is string theory. String theory states that in each subatomic particle, there are one-dimensional strings inside them. What I've drawn here are some branes, or dimensions of space. In string theory, it states that open strings must be only withheld in one dimension or brane, and closed strings can move between these dimensions. Gravitons have this very unique personality to them, which makes them very special. Relating back to string theory, when we look into space, we notice that there are gravitational lenses formed, even when there shouldn't be. These are formed through high areas of gravity. Now, we have given a theory to this as dark matter, matter that we can't see. However, a theory for this is that gravitons, as they have closed strings, they're able to leak through branes and into here, creating gravity. Now, do you remember when we found gravitational waves? The reason that was so hard to find these was because gravity is such a weak force that even us jumping overcomes it. Now, to find these waves, we had to create different LIGO systems across the world, detectors for gravitational waves. So there would be a LIGO system here and one here. And the only way we were able to notice this was when two black holes were able to collide, and that's only when we were able to find them. If we do find gravitons, which are so much harder to find, they would have a mass of 0 and a spin of 2. Thank you for watching. I hope you can appreciate that even the oldest theories are being developed today.